Hi there, in this video I'm going to do a past exam question on differentiation. So let's take a look at this question. Question number 3. A curve has parametric equations x is equal to 7 cos t minus cos 7t and y is equal to 7 sin t minus sin 7t. And they've given you the range for t. T lies between pi over 3 and pi over 8. In part A of the problem, we need to find an expression for dy over dx in terms of t, and you need not simplify the answer. So let's think about this question. Let's get back to the paper and pen. So here are the parametric equations. Now, if you're not aware or if you're not sure about parametric differentiation, I have created a video on this with examples, and I'll give a link to this video in the description below. However, let me show you how this is done. Now, to differentiate parametrically, first we need dx over dt and dy over dt. So we need to differentiate both of these with respect to t. So x in this case is 7 cos t minus cos 7t. Let's work out dx over dt. So when we differentiate cos, it's minus sine. So we're going to have minus 7 sine t. Derivative of cos is minus sine, but remember you need to multiply by 7. So since the derivative of cos is minus sine, 2 minuses is a plus, so we're going to get plus 7 sine 7t. So that is what you should have for the derivative of x with respect to t. We also need to differentiate y with respect to t. So y is 7 sine t minus sine 7t. So let's work out dy over dt. So bearing in mind that the derivative of sine is cos, we're going to have 7 cos t. And again, the derivative of sine is cos, but you need to multiply by 7. So you're going to have minus 7 cos 7t. Now we have dx over dt and dy over dt. But to work out dy over dx, we also need to calculate dt over dx. So let me show you how to calculate dt over dx. To work out dt over dx, all we do is we need to work out the reciprocal of dx over dt. So 1 over dx over dt gives us dt over dx. Now, since we have dx over dt, let's just substitute in. So we have 1 divided by dx over dt, which is minus 7 sine t, plus 7 sine 7t. So this is the answer for dt over dx. And using the answers for dy over dt and dt over dx, we can now use a chain rule to work out dy over dx. So by the chain rule, dy over dx, that is dy over dt times dt over dx. Now, let's put the results that we have for dy over dt and dt over dx. So for dy over dt, we had this. So let's copy this down. So we have 7 cos t minus 7 cos 7t. So that is what we have for dy over dt. Times, so times dt over dx, and here's the solution for dt over dx. So let's copy that down. So we have 1 all over the minus 7 sine t plus the 7 sine 7t. Now, if we multiply, so dy over dx, so let's see what we're going to get as a result. Dy over dx, so this term times 1, so we're going to have a 7 cos t minus 7 cos 7t on top, so that will be the term in the numerator, all over this term in the denominator, so minus 7 sine t plus 7 sine 7t. So if we go back to the question quickly, the question did say we need not simplify the answer. So going back to the paper and pen, so let's leave our solution like this. So that is the solution for dy over dx. Part B is we need to find the equation of the normal to the curve at the point where t is equal to pi over 6, and we need to give our answer in its simplest exact form. So let's think about what we need. To work out the equation of the normal, so we have dy over dx, we have the solution for dy over dx. So if we go back to the paper and pen, here's our solution for dy over dx. And in order to work out the gradient of the tangent, so that's what we need to do first, we can put the value of t given, which is pi over 6, into our solution for dy over dx. So let's work out the gradient of the tangent first. So let's work out the gradient of the tangent. Now I call my tangent gradient m1. So m1 will be, so let's remind ourselves, dy over dx is 7 cos t. Let's replace the t's by pi over 6. So it's 7 cos, so 7 cos t, which is pi over 6, minus 7 cos 7, so minus 7 cos 7, and t again is pi over 6, all divided by, and let's remind ourselves, in the denominator, minus 7 sine t is pi over 6, so minus 7 sine t, which is pi over 6, plus a 7 sine 7 and t, which is pi over 6. So plus a 7 sine 7 and t, pi over 6. So that is what it should have as a result of replacing the t by pi over 6. Now, if we simplify that, so m1 will be, now provided that your calculator is in radian mode, and if you input this into your calculator, you should have an answer of minus root 3 when you plug this into your calculator, provided that the calculator is in radian mode. And the question did say that our answer needs to be in exact form, so I'm going to leave it in surd form. Now, going back to the question, we need the equation of the normal. So we have the gradient of the tangent, and remember, since the tangent and the normal are perpendicular to one another, to work out the gradient of the tangent, we can use the property that if two lines are perpendicular, the product of their gradients equates to minus 1. So let's go back to the paper and pen. So to find the gradient of the normal, and gradient of the normal, I'll name that m2. We're going to use the property that m1 times m2 is minus 1. So the product of the gradients equate to minus 1 since the tangent and the normal are perpendicular, or since we have perpendicular lines. And m2, our normal gradient, when you rearrange, is minus 1 over m1. Now m1, bearing in mind we have that value of minus root 3. And if I replace in this rearranged form, I'll have minus 1 over minus root 3. And we can rationalise this. So if you rationalise this by multiplying the numerator and denominator by root 3, you're going to end up with root 3 over 3. So root 3 over 3 being the gradient of the normal. Now, what else do we need? So let's go back to the question. So we have the gradient of the normal. Now, we also need the coordinates of the points. We have the value of t. The value of t given in the question is pi over 6. And if we insert that value into the equations for x and y, we can work out the coordinates. We can work out the coordinates x and y, and this is vital to work out the equation of the normal. So let's do that. Let's work out these coordinates. Back to the paper and pen. So we have the value of t, pi over 6. Let's put that into the x equation first. So x will be, so let's remind ourselves, x is 7 cos t minus cos 7t. So when I replace t by pi over 6, we're going to have x, which is, in this case, 7 cos t, which is pi over 6, minus cos 7 t, which is pi over 6. So again, provided that the calculator is in radian mode, and if you plug this in, you should have a value for x of 4 root 3. So remember, we need our answer in exact form. We'll leave it in third form. Doing the same, if I put the t value into the y equation, so remember the equation for y, that is 7 sine t minus sine 7t. So let's replace the t in that equation to give us 7 sine t replaced by pi over 6 minus sine 7t, which is pi over 6. And if we plug that into the calculator, and if your calculator is in radian mode, you should get an answer of 4 for y. So we're nearly there. We have the x and y coordinates. We now have the gradient of the normal. So the gradient of the normal is root 3 over 3. So we have everything that we need to work out the equation of the normal. Since the normal is a straight line, let's use a straight line formula to work out the equation of the normal. So the equation of the normal at the point 4 root 3 and 4, the x and y values. Here's the formula for the line. Y minus y1 is m into x minus x1. So x1 and y1 in the formula are the coordinates where the line passes through. So our normal passes through 4 root 3 and 4. As for m is the gradient of the normal. So m is m2. m2 is root 3 over 3. So let's note that, root 3 over 3. Let's continue. So we'll have y minus y1 is 4. That is equal to m. m is root 3 over 3 into x minus, and x1 is 4 root 3. Let's get rid of the brackets. So on the left hand side you have y minus 4. So that's what you should have on the left. And when you multiply on the right, root 3 over 3 times x is root 3 over 3x. Root 3 over 3 times minus 4 root 3. So you're going to have minus 4 as a result. So be careful. So root 3 times root 3 is 3. 3 times 4 is 12. 12 divided by 3 gives you that 4. Now, these two minus 4s you can cancel. You have a minus 4 on either side. So the solution for y is going to be root 3 over 3x. That should be the equation of the normal in exact form. So that is the solution to part B, and that sadly ends this video. So I hope you found this video helpful. I hope you enjoyed this video. If you did enjoy the video, a like rating is very much appreciated. Do plenty of practice related problems, and I hope to see you again. Thank you.